Ryan here at the Anchorage House of Hobbies again. Thanks for tuning in for another episode of the Anchorage House of Hobbies How-Tos. Today we are going to cover lithium battery basics, specifically lithium polymer batteries or LiPos. The goal here is to help you understand your batteries to get the most out of your models. First, we'll go over voltage and amperage, we'll go into pack configuration, and then we will talk about C rating and what that does for you. All right, let's get into it. First is voltage or power, generally represented by a V on your battery pack. Now, we'll talk about a single cell as opposed to the whole pack. A single LiPo or lithium polymer cell has a nominal voltage of 3.7 volts. Nominal means the midpoint, where they are the most stable. So the proper voltage of a standard lithium polymer pack is 3.0 volts at full discharge to 4.2 volts at full charge. We'll talk about storage later, but storage is right in the middle at 3.6, 3.7, 3.8 volts. That's for another video though. Anything above or below that 3.0 and 4.2 will be damaging the cells. Now, an important thing about batteries to understand is batteries are passive. Power is pulled from them. It doesn't push power out. It's a common misconception. Now, if you picture the battery as a jug of water, the voltage can be represented by the pressure of that jug, how much power it contains. The next important spec is milliamp hours, or the capacity of the battery. That tells you how long the charge will last, how much energy the battery stores. The higher the milliamp hours, the longer the runtime. Now, a 1,000 milliamp battery equals 1 amp hour, just like 1,000 millimeters equals 1 meter. A 5,200 milliamp battery equals 5.2 amps. Now, a 1,000 milliamp battery with a load of 1 amp theoretically will last 1 hour if there was zero loss and everything was 100% efficient. Now remember, I say load of 1 amp. Batteries are passive. It requires something on the other end to pull that power out. Now if we go back to the water jug analogy, then the capacity or milliamperage is represented by the physical size of the jug, how much volume it has and how much it contains. Okay, so those two basics allow us to move into the configuration of the battery pack. So far we were talking about a single cell. There is parallel and series. First, we'll talk about parallel. Parallel means that they work side by side at the same voltage, but that increases the milliamperage. So if you have two of those 1,000 milliamp, 3.7 volt cells and you wire them in parallel, you get a single pack of 2,000 milliamps at 3.7 volts. Now, you can picture a pair of air fans. If you put them next to each other in parallel, they will move twice the amount of air, but it will move at the same speed as a single fan, same velocity. Next, we have series. Series means taking those batteries and putting them in line and increasing the power or the voltage, but the milliamperage remains the same. So those same two 1,000 milliamp, 3.7 volt cells, if we wire them in series, we have a single 1,000 milliamp 7.4 volt pack. You take that 3.7 volts and you add it together. Using those fans, if we put them in series, they move the same volume of air, but at double the speed, double the velocity. When you are looking at your battery pack, it'll have an S in the specs, a 1S, 2S, 3S, 4S, so forth. That S stands for series. So a 2S is 2 cells in series. 3S is 3 cells in series. And remember, we add that voltage number together. So a 2S, or two 3.7 volt cells together in series, equals 7.4 volts. 3S, 3 times 3.7 volts is 11.1. 4S times 3.7 volts is 4.8 volts. Again, that's the nominal voltage. That's not fully charged or fully discharged. Occasionally, you'll run into a battery pack that has a P on it. And so that tells you that there are cells within that battery pack that are wired in parallel. If you have a 2P, that means you've got two cells or two banks of cells wired in parallel. So if we use those 1000 milliamp 3.7 volt cells, we take 4 of them and we configure them in 2S, 2P, 2S, 2P, then we have a 2000 milliamp 7.4 volt pack. Okay? Get a little more complicated. If you have a pack that is 5200 milliamps and it says 4S 2P, inside that pack consists of 8 single cells. It's 2 banks of 4 cells in series, and they are all 2600 milliamps added up together to make a 4S 2P 5200 milliamp battery pack. On most battery packs in our industry, there are 2 leads coming off of it. There is the main power lead, which you would connect to your speed control or your charger. And then there is the balance lead. That's the smaller lead. Now, the balance lead is monitoring each individual cell in the battery pack. If you see, there is always 1 extra wire on there compared to the number of cells in the pack. That is because of how it's wired. Now, the black wire, or the ground wire, is the ground for the first cell. The second wire is the positive of that first cell. If you were to put a meter there, you would read that single cell. That second wire is also the ground for the second battery pack. The third wire is the positive of that second battery pack. So if you put a meter on the second and third connection in the balance cell, you would be reading only the second battery pack, the second cell in that pack. If you read the first and the third, you'd be reading the voltage of the total voltage of cell 1 and cell 2. And this goes all the way through 3, 4, 5. So if you have a 4-cell pack, there's actually 5 wires on there. That is how your charger pays attention to each individual cell. But again, charging is for another video. Finally, the main spec on batteries is the C rating, and that tells us the load capacity of the battery. The C specifically stands for current rating. Current rating, it directly relates to the internal resistance of the cell. The higher the C rating, the lower the internal resistance. Lower internal resistance means the cells can release their energy more efficiently. Remember, batteries are passive. That power is being pulled from them. So any internal resistance impedes that, causes heat, restricts the flow of that energy being released. So a higher C rating lowers that resistance, and you get less heat buildup. You get more punch from your pack, and it can support a higher load. Now, if we go back to the water analogy, the water jug, the C rating is represented by the size of the hole or the opening in that jug, how quickly that energy can be pulled from it. Now, when you use the C rating, and to tell you the amp load the battery can support, you multiply the C rating by the amp hours, not the milliamp hours. And then that will give you the amp load that that battery can support. So if we have a 1000 milliamp battery, that's 1 amp. If it's rated at 10C, you multiply 1 amp by 10C, that battery can support a 10 amp load. If that 1000 milliamp battery is 20C rated, then it's 1 amp times 20C can support a 20 amp load. If we have a 5200 milliamp battery rated at 50C, that's 5.2 amps times 50 is 260 amp load. Now, generally, that C rating is spec'd at continuous load. Pardon me. It's not always, but most of the batteries in our industry, it's continuous load. That's how much amp draw can be supported over the charge life of the battery pack. Typically, the burst rating, or a small amount of like a 5-10 second load, is as much as double the continuous load. So you'll see packs that say 50C/100C. That means it can continually take a 50C load, 50 times its amperage, but for a short amount of time, it can take 100 times. Again, that's not always. Double check, some batteries are rated, their C rating, as the burst load. Don't get confused by that. That will cause you problems. So, that about wraps up lithium polymer battery basics. Keep an eye out for our next video where we'll cover battery charging and storage. If you have any questions, shoot us a message down in the comments. If you like what you see, hit like and subscribe. Go follow us on Facebook and Instagram. Thanks for tuning in. I hope this was helpful for you. I'm Ryan with the Anchorage House Hobbies. Have fun.